This is question 1 of paper 2 of the AS Biology 2017. It starts off by asking you all those things that you learned at the very beginning of AS in year 12. And it starts off with a typical question from AQA because they don't want to know that you know about glycogen, they don't want to know that you know about cellulose, they want to know what are the differences between them. And indeed, that's what it asks. Describe 2 differences between the structure of a cellulose molecule and a glycogen molecule. And remember, we're trying to give the most straightforward answers that get us the marks. We're not trying to be clever. So we're just going to go for the most common answers that we're given, and that is that cellulose is made of beta-glucose and glycogen is made of alpha-glucose. I'm going to say that cellulose is made of straight chains and glycogen is branched. Now, where students lost their marks here is they didn't give the comparative statement. They might have said cellulose is made of straight chains, but they didn't say that glycogen is branched. By not being explicit, you're asking the examiner to do the work, and therefore you're not going to get the mark. Other accepted answers are shown here. Next question asks, starch is a carbohydrate often stored in plant cells. Describe and explain 2 features of starch that make it a good storage molecule. So we've got to do 2 things. We've got to describe the feature and we've got to explain the feature. Pause the video now and have a go at that question. Because of course we all know that as soon as you see the mark scheme, you're going to think, yeah, I would have written that, but let's just pause it and have a little think. The mark scheme only wanted 2 answers and there are 5 available, so quite an easy question really. And we're going to follow the same basic pattern. We're going to describe it and then we're going to explain it. So the first thing we're going to say is that it is insoluble. And by that we mean insoluble in water, of course. And to explain it, we're going to say that it doesn't affect the water potential. Now remember, we're at A level here, so we need to be talking in terms of water potential and not osmosis. Second thing, it's branched, so the molecule is more compact, meaning we can get more into the cell. Third, it's a polymer. That's the description of alpha-glucose, so this provides glucose for respiration. 4, it's branched, so more ends are available for fast breakdown by enzymes. And 5, it's a large molecule, so it can't cross the cell membrane, it can't leak out. Once it's in the cell, it's there. Where students lost most of their marks here was they didn't explain. They might have described it as insoluble or branched or a polymer, but they didn't explain how that helps it become a good storage molecule. Moving on to the next question, it says tick the box that identifies the test that would be used to show the presence of starch. Well, this goes back to year 7, and of course we know it's iodine solution. And just as a point of interest here, it's written like this, i.e. iodine backslash potassium iodide test, because iodine is a solid and it's insoluble, and the only way you can dissolve it is by dissolving it in potassium iodide solution. And that gives us what we have referred to for many years as iodine solution. Moving on to the next question, it says figure 1 shows a section through a plant tissue at a magnification of times 500. Calculate the actual diameter of the starch grain between points A and B. So the first thing I would do is write out the formula. Magnification equals image over actual. I remember it as mere. And then what we need to do is look at what figures we actually have. We have the magnification. We have, if we use a ruler, a measurement of the image, which is 20 millimeters. And so we're calculating the actual. And all we need to do then is rearrange that formula to make the actual the object of it. Try to get into the habit of remembering that centimetres do not exist in biology. Centimetres cubed do, which is the same as a milliliter, but centimetres in terms of a linear measurement doesn't. We always measure in millimetres. And then we can remember that it's a factor of 1,000 that takes us to micrometers. So 20 millimetres becomes 20,000 micrometers. All I need to do then is to divide that by my magnification, which is 500, and it gives me the answer of 40. And most students who got this wrong were unable to convert millimetres into micrometers. So just remember, it's a factor of 1,000. What does that mean? You measure it in millimeters and you bung 3 zeros onto it, and that converts it to micrometers. And the next question asks, what type of microscope was used to obtain the image shown in figure 1? Give one piece of evidence to support your answer. A nice, easy 2 marks here. We can see it's got a 3D image. And the only microscope that makes a 3D image, of course, is a scanning electron microscope, where they chuck the electrons at it and the way they scatter off gives us the image. And so most students who got that wrong referred to a black and white image and therefore called it a transmission electron microscope, which of course is wrong because the 3D image gives it away that it's a scanning electron microscope that we've used. I do hope you found the video useful. Please leave me a comment and thanks for watching.